Hello. You know what? 99% of students will fail this. 99% of students will fail this. So I urge you to pay attention to the end of this video so that you can discover the tricks behind this question. The question says, differentiate cos squared x with respect to x from first principles. From first principles. Okay, here's the suggested solution. Here's the suggested solution. Let's say y be equal to cos squared x. Differentiating this trig function with the even powers, you have first convert them into double angle formula. So from here, I would want you to recall this concept. The first one is this one, sine squared theta plus cos squared theta equals 1. This is the first concept which I want you to recall. Then the second one is this, that cos 2 theta. This is equal to cos squared theta minus sine squared theta, of which from here we get cos squared theta minus into bracket. Now let's use this concept for this particular sign here. So it will be 1 minus cos squared theta, which gives us cos squared theta minus 1, then plus cos squared theta. Here we get 2 cos squared theta minus 1. So making cos squared theta the subject of this particular formula, we shall have cos squared theta to be equal to, taking this one that side, so it will be 1, then plus cos 2 theta. Okay, dividing both sides by 2, this is what we shall get for the right hand side. So now what do we have to do? Now our y becomes a half into bracket 1 plus cos 2 theta. Okay, when you differentiate from first principles using this expression, it becomes a bit easier than when you're doing it direct from here. There's a lot of complications here, but the easiest trick is to use this expression. So how do we go about now differentiating from first principle? From our question, as regard to our question, we shall have now our y to be equal to a half, then plus, this will be cos, now we're replacing theta with our x, so it will be 2x, then you divide by 2. This is our y. So if differentiating from first principle is all about looking at what happens to the increments of the respective values of x and y when they tend to a certain limit. For example, if delta x be the increment in x, then we expect delta y to be the increase in y. So if this is the case, then what happens from first principles? Add delta y to y, so it will be y plus delta y. This will be equal to, and add delta x to every x which is in this expression. So it will be a half, then plus, this is cos 2 into bracket, now our x becomes x plus delta x. You see this? Then let's divide by our 2. This is what we have. So this implies that now we take y plus delta y as the first term minus y, that's on the left hand side, will be equal to the right hand side, which is this one. The right hand side is this. It's a half plus cos 2 into bracket, this is x plus delta x, divide by 2, minus our y is a half, plus cos 2x, our y is equal to this one. Okay, so let's open our brackets because the sign between the two terms is minus. So if you can open the bracket, let's first start with the left hand side here. we have this minus this. Here definitely we shall get delta y. This will be equal to, on the right hand side, we have this a half here. The sign is minus, so it's a half minus a half. That one is 0. Then we have this complicated term, which is cos. Now it's going to be, if you open the brackets here, it will be 2x, then plus 2 delta x. This one divided by 2, then minus cos minus cos 2x divided by 2, or here divided by 2. That's what we have. Let's take this 2 outside the bracket, so put a half there. Then here we shall have cos into bracket 2x plus 2 delta x divided by, do we divide by any term? No, now yes, 1. So if we divide by 1, it's the same as not putting it there. Okay, so it will be equal to this, then minus cos 2x. The addition of, the subtraction of 2 cosine. The subtraction of 2 cosine, here we have to recall another concept in the trig, which will help us to simplify this. And which one is that? Which one is that? Is this one. If I have cos, say, of angle A, then I minus cos of angle B, cos of angle A minus cos of angle B. This equals, we shall have negative here, then 2 sine, this is A plus B, divided by 2, then again sine, it will be A minus B divided by 2. Okay, so let's apply this concept here. Let's apply this concept there. This time round, you can take the whole of this part here, from here to here, take this to be your A, and take this one to be your B. Okay, now let's substitute these values in this expression. So this one will give us that now our cos 2x plus delta x minus cos 2x. This expression now will become, let's look here, it will be negative 2 sine. Okay, hope you're paying attention here. Negative 2 sine, then into bracket, first let's add this and this. Okay, I mean we are adding 2x plus delta x plus 2x. This automatically gives us 4x, then plus 4x plus 2 delta x divided by 2 in the first bracket. In the second bracket, we are subtracting is a minus b. So let's take the whole of this one, which is our a. I mean 2x plus delta x minus 2x. This will give us 2 delta x divided by 2. 2 delta x divided by 2. Okay, let's check. Yes, it's this one minus this, so remaining this. Okay, and what do we get now on the right hand side? On the right hand side, what do we get? Negative 2, then we have sine, negative 2 sine, 4x divided by 2, 4x divided by 2. Okay, this gives us 2x, and 2 delta x divided by 2, this gives us delta x. Then sine, 2 delta x divided by 2, this is delta x. This is what we get. Okay, either we can simplify it further. So this implies that, remember, the whole of this one was equal to, from up there towards this, is equal to delta y. So we shall say our delta y is equal to, first of all, there's this a half outside, this one. Then into the bracket, this is what we got. I mean negative 2, then sine, into bracket 2x plus delta x, then sine delta x, like that. What is next now? Since this is multiplication, so the bracket is the multiplication, then this divided by, I mean, a half times -2. This gives us negative. This gives us negative. This will become sine 2x, then plus delta x, then sine delta x. Okay, sine delta x. Remember, this value is equal to delta x, and to be able to differentiate, we need to have a dy dx. So what do we do next from here now? What do we do next from here now? I mean from here, where we have delta y is equal to negative sine 2x plus delta x into bracket sine delta x. Okay, to get that expression of dy dx, then we need to divide through by delta x. So dividing through by delta x, this is what we shall have. Y delta x is equal to negative sine 2x plus delta x, then sine delta x divided by delta x. This is what we said. So now what happens here? This expression now we have arrived at. Now this is the point where now you start considering having limits. Okay, this is the point now where you start having limits. So what do we say about the limits now? Let's look at the delta x, because it's the one which impacts the delta y. So we say as the delta x tends to 0, as delta x tends to 0, what happens to delta y over delta x? Delta y over delta x, this one will tend to dy dx, the one we are looking for, comma. Then what will happen to sine delta x over delta x? This one will tend to 1. Are we done? Not yet. And what happens to this term? I mean this term sine 2x plus delta x. This one tends to, if delta x is 0, this one tends to sine 2x. Tends to sine 2x. So now what do we say about the whole of this expression? If these are the conditions in their respective outcomes, then what happens to this one? So therefore, we get our dy dx. We said we already have the limits. Now we're replacing the delta y, delta x with the dy dx, which equals the negative still remains. We have the first term as sine. What do we say about this one? We said as delta x tends to 0, then sine into bracket 2x plus delta x will tend to sine 2x. So it will be sine, this is 2x. Then the next term is this one. What did we say about this one? We said sine delta x over delta x will tend to 1. So multiplying by 1, okay? Multiplying dot here means multiplication. Multiplying by 1, then we shall have our final answer, that is dy dx, to be equal to negative sine 2x. Okay, did you get that? Yeah, if you got, congratulations, you are a genius. Please follow and put your comment so that others also can benefit from this information. Thank you.